Hello again, welcome to another lesson in geometry. Today we are covering section 6-3, proving that a quadrilateral is a parallelogram. So last section we learned about parallelograms and some of their properties. In this section we're going to try to take a quadrilateral and prove that it is a parallelogram. All right? So first off, let's get a little review here. Does a pentagon have opposite sides? So remember, a pentagon is five-sided shape. And if I had a side over here, I'll put it in green, which one would be its opposite? Well, it can't be the ones that are next to it. That's a consecutive side. But would it be this one or would it be that one? So only even-sided polygons will have opposite sides. So this is no. Does an n-gon have opposite sides if it's an odd number n? And this would be no. No odd numbered n is going to have opposite sides. Okay. All right, so draw a line from each side in column A to the opposite side in column B. So AB is going to be opposite of DC, and AD is going to be opposite of BC. All right, so the opposites are across from each other. The two in green are opposite, and the two not in green are opposite. All right, we have a vocabulary builder here. So parallelogram. A parallelogram is a quadrilateral with two pairs of opposite sides that are parallel. And opposite sides may include arrows to show the sides of the sides are parallel. So two pairs of opposite sides that are parallel to each other. That's all it is. Okay. Doesn't tell anything about the lengths of the sides. It doesn't tell anything about the angles compared to all of them compared to each other. So they don't have to be right, or they could all be right. It doesn't matter. Okay. All right. So we have related words are square, rectangle, and rhombus. And these are related because all of these are also parallelograms. Okay. All right, so what if P, write P in the statement if it describes a parallelogram, or NP if it does not. So an octagon cannot be a parallelogram because it's five-sided and a quadrilateral is four-sided. So this is not a parallelogram. Five congruent sides. Once again, not a parallelogram because a parallelogram can only have four sides. A regular quadrilateral. So a regular quadrilateral is a square, and a square is a parallelogram because the opposite sides in the square are parallel. So this is a parallelogram. Write P and the figure appears to be a parallelogram, or NP if it does not. So let's see, I think this side looks parallel to me, and these two look parallel to me, so I'm going to say P for parallelogram. I think these two look parallel to me, but the other two definitely not. So I'm going to say NP for not a parallelogram. And in our last one, I think these two are parallel and these two appear to be parallel. So I'm going to say P for a parallelogram. All right, let's flip it over and check out the second page. All right, at the top of the second page, we just have a whole big list of theorems here. So it's theorem 6-8 through theorem 6-12. So if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if the opposite sides are congruent, notice it's not saying anything about being parallel at all. Just, hey, this side over here is congruent to this side over here. And this side here is congruent to this side here. Automatically a parallelogram is going to form. Okay? If an angle of a quadrilateral is supplementary to both of its consecutive angles, then we're going to have a parallelogram also. Okay, so if this angle over here, maybe we'll call it 80, and this angle right here, maybe we'll call it 100. See, these are supplementary, and then the other way for 80 would be up here. Okay, this would have to be 100 also. When you're done, you're going to end up with a parallelogram again. All right. Theorem 6-10 says if both pairs of opposite angles of a quadrilateral are congruent, then you're going to get a parallelogram again. So we'll draw something like this. This angle and this angle have to be the same. And if this angle and this angle the same, we're always going to have a parallelogram. Okay. So if you have a quadrilateral and the diagonals bisect each other, you're going to get a parallelogram. So here's a quadrilateral. If these two bisect, you're going to have a parallelogram. So if one pair of opposite sides of a quadrilateral is both congruent and parallel, so notice it's completely ignoring the other one, then we have a parallelogram. So here's one set of sides that have to be parallel. and they also have to be equal in length. So that's going to form a parallelogram. All right, so use the diagram at the right in theorem 6-8 and 6-12 for exercises 11 through 16. All right, so let's take a look at this. If AB is congruent to something and BC is congruent to something, then we have a parallelogram. All right, so we're supposed to use 6-8 through 6-12. So if the opposite sides of the quadrilateral are congruent, then we have a parallelogram. So that's what they're going for here. AB is opposite of CD, so these have to be congruent. And BC is opposite of AD, so these two would have to be congruent to get a parallelogram. So this is AD. Okay. So if the measure of angle A plus the measure of angle B equals, let's see, so this is this one. We got something about supplementary in here. So if consecutive angles are supplementary, so A is going to be consecutive with B and with D. So this is saying if A and B make 180, and A and D make 180, then we have a parallelogram again. And that's because both pairs of consecutive angles have to be congruent. So A has to be supplementary with B, and it has to be supplementary with D to make the parallelogram. All right. If angle A is congruent to some other angle, and angle something is congruent to D, then we have a parallelogram. And this is using theorem 6-10. If both pairs of opposite angles of a quadrilateral are congruent, then we have a parallelogram. A is opposite of C, so these two have to be congruent. And B and D are opposite each other, so these two have to be congruent. Right? If AE is congruent to something, and BE is congruent to something, then we have a parallelogram. Okay, so I think what we're missing in this diagram is our E. And I'm pretty sure the E should go in this spot. So AE is supposed to be congruent to CE, so that the diagonals will bisect each other. And BE should then be congruent to DE. This shows that the diagonals are going to bisect, so that this length is here, and this lengths are here are the same. All right. All right, so if BC is congruent to the opposite side, AD, opposite sides of parallelogram should always be congruent, and BC is parallel to AD, we have a parallelogram. That's this picture that came from here. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then you have a parallelogram. Okay, so BC and AD. And then we have if CD is congruent to AB, and CD is parallel to AB, then we have a parallelogram again. Okay, so that's the same one again. All right, that concludes the top here. So we have a couple problems down below. Problem number 1, finding the values of parallelograms. So use the diagram at the right. For what values of x and y must E, F, G, H be a parallelogram? All right, so what do we know here? Circle the equations you can use to find the value of y, and underline the equation you can use to find the value of x. So we're looking once again at probably a system of equations. All right, so let's see. Maybe not though. So I know that E and H should be supplementary, and those only include y. Okay, so here we go. We have y plus 10 plus 3y minus 2 equals 180. And that's really nice. I also know that, let's see, which equation will we use here also? Y plus 10 equals 4x plus 13. That should be true. Opposite angles are going to be the same. We can use that to get x once we've already solved y. And then the other one, y plus 10, should not equal 3y minus 2 because those are consecutive, so that's not going to work. So we're going to cross this one off, and it said for us to underline the equation you can use to find x, and circle the equation you can use to find y. So I should have underlined this one. Sorry. All right, so find our y. So our y1 could be found by looking at angles E and H. They both use just y, and they should be supplements of each other. So we can use y plus 10 plus 3y minus 2 equals 180. So that's 4y plus 8 equals 180. So 4y is equal to 172. And that means that y's value is going to be 43. Okay, and then we have to find x. So we can plug into our second equation, which we couldn't find x without having y first. So it's a little tricky here. You got to get the y part first. So if we get x here, we're going to put 43 where y is, and then solve for x. So we have 53 equals 4x plus 13. Subtract 13 from both sides. So we have 40 equals 4x, and that means x is 10. So what equation would you use to find the value of x first? Okay, so we could have done that. If you look at f and g, those are consecutive. So those should add up to 180, and they have only x in them. So we could have used the equation 4x plus 13 plus 12x plus 7 equals 180. And if we solve that one, we would get the same value of x. So EFG must be a parallelogram for the values of x equal to 10 and y equal to 43. Well, why is that the case? Well, if you plug them back in, then it's going to show that opposite angles are congruent and that consecutive angles are supplements. All right, let's flip it over and look at page 3. Okay, on the top of page 3, we have problem number 2, decide whether a quadrilateral is a parallelogram. So can you prove that the quadrilateral is a parallelogram based on the given information? And our given information here is only that EF is congruent to GD and that DE and FG are parallel. Okay, so we don't have two sets of parallel lines. We don't have two sets of congruent lines, so we can mark those out. So we can check on the angles. We either have to prove that opposite angles are equal, congruent to each other, or that one angle is supplementary to both of its consecutive angles. So let's see if we can do either one of those. All right, so circle the angles that are consecutive with G. So the angles that are consecutive with G are going to be D and F. Underline the correct word to complete the sentence. Same side interior angles formed by parallel lines cut by a transversal are either going to be complementary, congruent, or supplementary. So let's draw a set of parallel lines and remind ourselves. Here's our transversal. And same side interior are these two. They are certainly not congruent, but they are supplementary. Okay. Remember, alternate interior are congruent and none of them are complementary. So circle the interior angles of the same side of the transversal DG and underline the interior angles on the same side of transversal EF in our parallelogram. All right, so DG cuts across here, and the angles that are on the same side of DG are going to get circles. So that's angle D and G. These are going to be supplementary to each other. And then E and F are going to get underlines, and these are supplementary to each other. So our underlined ones are supplementary, and our circled ones are supplementary. All right. So can you prove that that quadrilateral DEFG is a parallelogram, and explain? And this should be no. Okay. I don't know if what they show you above is really good at this explanation, but we don't have anything on here about anything about congruent angles, so we can ignore the opposite angles are congruent. So what we really want to know is, can we show that G is supplementary to both D and F at the same time? And this isn't possible. So no angle is supplementary to both of its consecutive angles. Now you might look at that picture up there and say, well, it should be. Look at it. It could tell that's a parallelogram. But let me draw the picture a different way. So here's my two parallel sides, okay? And we'll put one of them right here. They're definitely parallel, right? All right, so let's see, draw that a little bit different. So here's my two parallel sides. They're definitely parallel. And then here are my two congruent sides. Okay. So the red ones can be congruent, the green ones can be parallel, but it doesn't make it a parallelogram. So if you draw it like the picture that was done for you, it looks like it should be a parallelogram, but you got to think, oh, is there another way I could draw that picture to make all that stuff true and it won't be a parallelogram? Okay. All right. Let's take a look at the next problem. Problem number 3, identifying parallelograms. So a truck sits on a platform on a vehicle lift, and the two moving arms raise that platform up. So the moving arms are here and here, okay, and then there's the lift. And you can see that that lift forms a parallelogram with the arms and the floor, okay? So what is the maximum height that the vehicle lift can elevate the truck? Explain. Well, that's pretty obvious. It's going to be 6, but let's go through the steps. Do the lengths of the opposite sides change as the truck is lifted? Well, yeah. No, they don't. Okay? They're going to stay 6 all the time. So the lengths of the arms will always be 6. Doesn't matter whether the truck is at 6 feet or not. It's just the length of that arm is going to be 6. So the least and greatest possible angle measures for P and Q are going to be 0 if it's on the ground, or 90 if it's straight up. Okay? The greatest possible height is when P and Q are both 90. Okay? So what is the maximum height the truck is going to be when they're both 90? Well, it's going to be 6. And that's because a parallelogram is its tallest when it's a rectangle. The tallest a parallelogram ever gets is when it's a rectangle. Remember, every rectangle is a parallelogram. So to maximize that length, how big the arms can go up, always make it into a rectangle. All right, flip it over. On our last page, we have our lesson check. So as always, pause the video here, try your lesson check, and then come back and see if you understood everything. Welcome back. So our lesson check, compare and contrast. So how is 6-11 in the lesson different from 6-6 in the previous lesson? In what situations would you use each of these theorems? And then we need to explain. So theorem 6-6 says, let's see, if a quadrilateral is a parallelogram, then its diagonals bisect each other. And theorem 6-11 says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we're supposed to circle the hypothesis and underline the conclusion. So in our first one, we're given a parallelogram, and we know that its diagonals bisect each other then. And in the second one, we know that some quadrilateral has angles, or some quadrilateral has diagonals that bisect each other, and then we can tell that it is a parallelogram then. Okay, so these are the converse of each other, right? Spent a lot of time looking at those. So that's just flipping the A and B, but not negating anything. So draw a line from statement in column A to the corresponding statement in column B. So a quadrilateral is a parallelogram. That means we're starting with a parallelogram. And the diagonals of a quadrilateral bisect each other. That means we're starting with that one. Okay. So circle the word that describes how theorem 6-6 and theorem 6-11 are related. So these are converses. Now, when would we use each one? Okay, so we would use 6-6 if we wanted to talk about the parts of a parallelogram. So prove something about parts of a parallelogram. Okay. So we use this when given a parallelogram and wanting to use the diagonals. Okay. And we use 6-11 not when we're given a parallelogram. We use 6-11 to prove we have a parallelogram. Okay, So if we want to prove we actually have a parallelogram, we use the 6-11. That says, hey, those diagonals bisect each other. Boom, you have a parallelogram. 6-6 is to say, well, I've got a parallelogram already, and I want to use the fact that the diagonals bisect each other. So then I can use that as facts, okay? Just like I can use that the opposite angles are congruent, or that the consecutive angles are supplementary, or that the opposite sides are congruent, okay? So check off the vocabulary words that you understand. So hopefully you definitely understand the diagonals now, parallelograms, and quadrilaterals. So four-sided shape, and then there's a special four-sided shape where opposite sides are parallel. How well can you prove a quadrilateral is a parallelogram? If you don't remember any of those ways we could do it, then you need to go back and look over the notes. So we came up with a list of, let's count them again, 1, 2, 3, 4, 5 ways to prove that quadrilaterals were congruent. All right, I'll see you in class next time.